Hello everyone, a very good afternoon to dear Mess sir and all my classmates. This is Gaurismita Naik of class 10 from Odisha Adarsh Vidyalaya, Chapathanda, Nalla. In today's mathematics seminar, my representation is based on the fundamental theorem of arithmetic. So before we know about the fundamental theorem of arithmetic, first we should know about the prime factorization, because the prime factorization is closely linked with the fundamental theorem of arithmetic. So what exactly is prime factorization? So let us understand. To understand prime factorization, we just need to understand two things. First, prime numbers, and second, factors. Let us understand factors first. So what is factors? Let us consider a number 12. To find its factor, we just need to write 12 as a factor of two positive integers. It can be written as 3 times 4. It can also be written as 2 times 6, and the product of 1 and the number itself, that is 1 into 12. So the numbers 1, 2, 3, 4, 6 and 12 are the factors of 12. So from now we know that what factors are. Let us move on to the second concept, that is prime numbers. So the numbers is of only two factors. One in itself is called prime numbers. For example, 2, 3, 5, 7, etc. But the numbers which are not prime and more than two factors are said to be a composite number. For example, 4, 6, 10, 9, etc. So prime factorization means writing a number as a product of two positive integers, as a product of prime factors. Writing 12 as 2 into 2 into 3 is a prime factorization of 12. Just like that, we can also factorize 144. So 144 can be written as 2 into 2 into 2 into 2 into 3 into 3, that is 2 to the power 4 into 3 square. Prime factorization is also used to find SCF and LCM of any numbers. Let us find the SCF of 72 and 108 by prime factorization method. So when we factorize 72 and 108, we get, so here the prime factorization of 72 and 108 is 2 square into 3 square, that is 36. And just like that, we can also find the LCM of 36 and 48. So we are clear that what is prime factorization. So SCF and LCM also connected with the important formula, that is SCF into LCM is equal to product of two numbers. So fundamental theorem of arithmetic, we know that a set of rational and irrational number is called real numbers. So we can say that all the natural numbers are real numbers. All the natural numbers which are composite by using their prime factorization method, we can write them as a product of primes. For instance, 8 can be written as 2 into 2 into 2, and 18 can be written as 3 into 3 into 2. Every composite number, from that we conclude that every positive number can be uniquely expressed as a product of primes. But the prime numbers like 2, 3, 5, 7 cannot be written as a product of primes. So the general form of x, a composite number x is equal to, can be written as general form of a composite number x can be written as p1 into p into p2 into p3 and so on into pn. So let us know how to use this theorem in proving any statement. The statement is 4 to the power ends with 0. If a number ends with 0, that must be a factor of 5, 2 and 5. It means a composite number which ends with 0, 5 and 2 must be a factors of that number. 4 to the power n can be written as, so if you observe in this expansion that these all are prime numbers. So we can say that as its prime factorization does not contain 5, so no 0 will come. I hope you all were understood from my explanation. Thank you.